Welcome to this new session of Transplant International Podcast.
Hello, everyone, and welcome back to the Transplant International Podcast, where we explore the scientific advances and clinical innovations shaping the future of transplantation. I'm Nina Pilat, Deputy Editor-in-Chief of Transplant International, and your host for today's April episode. Today, I'm very happy to be joined by my co-host, Dr. Antonio Citro, and also by our Editorial Fellow, Dr. Andrea Zajacova, who will help us guide us through the Editor's Choice papers selected for this month.
Great to be here, Nina. And this month we have 3 papers, actually, that each in their own way speaks to further of transplantation, digital, biological, and technological features.
Already looking forward to dive in. Welcome, Andrea. Thanks a lot for being here today to discuss the Editor's Choice papers of this month.
Hello, everyone. Happy to join today.
And before we begin, as always, a brief reminder, the views expressed in this podcast, they are our own and do not necessarily reflect those of Transplant International or ESOT. So let's dive right in, Andrea. Could you introduce our first Editor's Choice, the new ESOT position paper on artificial intelligence?
Of course, this paper is a major collaborative effort and a milestone in defining the role of AI for our transplant community. It's titled, Shaping the Future of AI in Organ Transplantation, position paper of the European Society for Organ Transplantation. What makes this position paper to stand out is that it's not a review of AI application, but it's a strategic framework where ESOT is settling out what responsible, trustworthy AI should look like in our field. The author structured this around 5 domains: high-quality AI development and methodological rigor, ethical considerations, especially fairness and access to care, the regulatory landscape, including the MDR and the new European Union AI Act, responsible clinical adoption, participatory design involving clinicians, patients, and the public. Moreover, this manuscript contextualizes all of aforementioned domains specifically within transplantation.
Thank you, Andrea. And that is what I appreciated here more. There are many generic AI ethics guidelines floating around, but transplantation is very different. We deal with absolute organ scarcity. There are life and death allocation decisions. There are profound equity considerations. So a transplantation-specific AI framework is overdue.
Exactly, I couldn't agree more. The authors emphasize that generic ethical language like avoiding bias is not enough. Transplantation needs practical and applicable guidance to provide answers for emerging questions such as what counts as a biased data set in organ allocation, or how do we handle underrepresented population, or how do we ensure transparency in models influencing graft acceptance decisions.
This is really important. And one theme that really stands out is data quality. The authors are very clear. AI can only be as good as the data it is trained on.
Yes, and they highlight 3 issues. There is heterogeneity across centers, including different definition protocols or thresholds. We have to deal with missing data, which is pervasive in transplant registries, and as well with limited representativeness, particularly where underserved populations are undercaptured. Hence, the key message is a fancy model cannot compensate for a flawed data set.
And here, I also like how they stress the need for multi-center development. Too many models in transplantation are built on single-center cohort and never validate elsewhere.
Yes, the ethics section is also very timely, especially given concerns about bias and equity in AI systems.
Right. They discuss algorithmic bias in risk prediction, potential inequities in AI-supported allocation, the risk that AI tools could amplify existing structural disparities, and the importance of transparency, not only technical, but also communicative transparency towards patient and the public.
Indeed, the point that I found particularly striking is the emphasis on maintaining public trust. Since the deceased donors depends on public willingness, and any perception of opaqueness or unfairness in AI argument allocation could undermine the entire system.
Yeah, the regulatory discussion is also quite detailed. Transplant professionals might not be fully aware of how AI systems are categorized.
Yes, the paper explained that nearly all AI tools in transplantation will be considered high-risk medical devices under European Union law. That means strict oversight, mandatory human control, stringent safety documentation, and transparent performance reporting. And importantly, current regulations are designed around static algorithms, but many AI tools are adaptive. The authors of the position paper call for a clearer life cycle oversight mechanism.
Yeah, but the responsible adoption section may be the most clinically relevant indeed. It addresses automation bias, the tendency for clinicians to follow an algorithm's output even when it contradicts over the evidence.
This might also be a real risk in transplantation. If an AI tool recommends accepting or declining an organ, clinicians they need to remain in command, not defer without critical thinking.
Yes, and they also discuss clinical deskilling. If too much AI is delegated to AI, we risk eroding human expertise over time.
Which is why the author emphasized AI literacy, not technically coding skills, but an understanding of how the models was built, how it performs, and where it is available.
Yes, and finally, participatory design.
Yes, and this is often overlooked. The authors argue that for AI to be clinically useful, the people who will use it, clinicians and patients, must be involved early. That means co-designing interfaces, reporting formats, and use cases so AI supports real clinical needs rather than hypothetical ones.
Yes. And what I appreciate about this position paper, that it's both aspirational and also practical. It doesn't hype AI, but it doesn't downplay it either. It lays out a roadmap to help the field move forward in a safe but meaningful way. A genuinely important read.
Yeah, and now it's time to move to the April cover article, long-term organ perfusion.
Yes, this review is comprehensive and clearly captures where the field is going. Traditionally, machine perfusion meant 4 to 12 hours of organ ex vivo preservation. However, that's been changing rapidly. This review highlights evolving timeframes for machine perfusion across different solid organs. Liver is being perfused for 7 up to 12 days, kidneys perfused for 48 hours, or even up to 4 days in recent works. Experimental lung perfusion up to 24 to 72 hours. Hearts being perfused for 16 hours in clinical cases, with ongoing work towards longer durations, and multi-day perfusion of vascularized composite allografts. The key insight is that extending perfusion beyond 24 hours creates therapeutic time. This transforms perfusion from a preservation tool into a treatment platform, allowing for active repair of ischemic injury, defattening of steatotic livers, metabolic stabilization and dialysis integration, gene therapies or anti-inflammatory interventions, functional assessment over a longer window, and potential regeneration of partial grafts.
So it's really like a change to just a preservation tool to a treatment or a therapeutic platform. And I also think the logistical implications, they are equally transformative here.
Yeah, absolutely. Long-term perfusion means the ability to plan transplantation during daytime hours, reduce need for emergency surgeries at night, potential for centralized perfusion hubs, and more efficient use of teams and resources. And this could indeed reconfigure how transplant programs operate. However, the review also addresses key limitations. Perfusate deterioration, including toxin buildup, hemodialysis and oxygen carrier instability, endothelial injury due to shear stress or oxidative stress, maintaining sterility during multi-day perfusion, and organ-specific demands. For example, the liver detoxifies in oats perfusate while kidneys or hearts cannot. The technical progress is impressive, but the authors are clear that long-term perfusion is still an evolving frontier.
That's really an excellent overview and one of the clearest reviews we have ever published. I think it will help the field conceptualize where machine perfusion is heading for the next decade.
Our final editor's choice takes us into fundamental biology with clear translational implications. We all know that cell-free DNA, especially donor-derived cell-free DNA, is a biomarker for allograft health, with increasing levels during allograft damage. However, the study asked, what if cell-free DNA is not only a marker, but also a mediator? The authors used a mouse model of warm ischemia and purified cell-free DNA released into bloodstream after a perfusion. When they exposed macrophages to this cell-free DNA, TNF-alpha, interleukin-6, and CXCL10 levels rose significantly. And this occurred even when netosis was eliminated by using PAT4 knockout mice. However, DNase-1 digestion almost completely removed the inflammatory response. This strongly suggests that cell-free DNA itself acts as a damage association molecular pattern, activating innate immune pathways. The author then tested the concept in rat liver normotrimming machine perfusion. When they added DNase-1 to the perfusate cell-free DNA levels dropped significantly, while perfusion parameters, flows, pressures, lactate clearance were not adversely affected. It raises the possibility that NMP could become a platform for cell-free DNA depletion before transplantation.
So at this stage, Andrea, I have a very naive point for you. We know that preclinical models are useful for data interpretation, but in your opinion, which is the clear gap that here we still need to complete the fully use of NMP as a potential platform for cell-free DNA depletion before transplantation?
Thank you very much. This is indeed a very interesting question, and I think the truly critical thing to address is the time window which we will need to remove cell-free DNA, as has been highlighted in the recent review we have discussed.
Thank you for your opinion, and it's fascinating because it changes our interpretation of cell-free DNA. It's not simply a sign that cells have died, it's actively shaping the inflammatory environment too.
Yes, and as highlighted in liver transplantation, where ischemia-reperfusion injury is still a major clinical challenge, targeting cell-free DNA could become a new therapeutic avenue.
So that finally brings us to the close of our April issue. 3 papers that each look at the different frontiers of transplantation. We actually touch base in AI and digital governance, long-term machine perfusion, and the inflammatory biology of cell-free DNA.
All 3 fields are evolving in real time, and these papers provide structure, depth, and direction.
Agreed. And we encourage everyone to read the full articles in the April issue of Transplant International. And as always, thank you, Antonio and Andrea, and thank you to our listeners for joining us today.
I cannot agree more with you. Thank you, Nina, and thank you, Andrea, for this great discussion and overview.
Thank you for having me.
Thank you, the both of you. This has been the April issue of the Transplant International Podcast. Don't forget to subscribe, and we'll be back soon with more conversations and insights from across the field.